Everyone, we're now at the last great eroder here, and this eroder took out a school.
The stuff of student dreams.
If you came across this is not the way they built the school. The last agent of erosion here caused the school to split in half. What is that agent?
Well, you can see one end of the school is down a lot further than the other one, and down to me generally indicates gravity.
So gravity is our last mover and shaper here.
Yes.
So one of the first ones we want to look at is a flow, particularly a mud flow. And a mud flow is really just a mixture of water and soil, and if it's on a hillside, it's going to move quickly. How come?
Generally starting off with an area that's not held together well by vegetation or anything else for that matter, and so when it suddenly rains a lot, then you get a lot of moisture, a lot of weight in the soil, and gravity then wants to pull that down more readily.
We discussed this a lot in volcanic activity. We said if volcanoes have snow up on their mountains and that snow melts, it can mix with the debris, the ash, and create lahars flowing downhill.
Very fast.
So another way that gravity can cause things to move is in a slump. A slump, again, is a mixture of water and underground material. But the rain now kind of decreases the friction between the surface material and what's underneath it.
Right, the underlayment gets sort of eaten away for whatever reason, probably because it's some different material, weaker material at the bottom. So when the bottom of the hill weakens, the whole thing kind of slides down as a result of this. They often present themselves as landslides. I mean, we see these things and we say, oh, there was a landslide. But there's a deeper, no pun intended, reason for this to happen.
So it's a very quick movement and maybe not as far-reaching as a landslide or a mud flow. So the reason the school was out is due to a slump. One half of the school has slumped down due to that weakening of the ground above it.
This is a really large slump that happened in, I believe this is California, the Conchita Slump. You can see that it can be very dangerous. A few of those houses were completely covered. There's a lot of damage involved here.
And it leaves that moon-shaped scar behind, so it's kind of a good indication that you've got an area where gravity made this whole area kind of slump away. A slower movement of gravity erosion here is known as the creep. So creeps walk really, really slow. They kind of sneak up on you, and again, because of water-soaked regions, gravity can kind of loosen the land and make it look like this.
Yeah, I hate when the creeps sneak up on me. And it seemed to have snuck up on this farmer's property. You can see there's a fence there. The fence posts have been completely obliterated by this. This is a really powerful example of creep right here.
So you've got the entire hill slowly moving away. It's not the quick movement of a slump, it's the slow tilting of fences. Because no one puts a fence in crooked.
No.
They put them in straight. No one puts the telephone poles in crooked. But the very slow movement of the hill moving away. The bent trees are always great examples that creep is happening in that region.
Yeah, this is the process that knocks down the retaining walls at your house. Ever so slowly, they keep on tilting until finally you have to replace them or rebuild them.
So we got the fast movement in slumps. We've got the slow movement in the creeps. Another fast movement here are landslides, where again, rock get loose. If they're not mixed with mud, then you've got rocks moving down the hill in fast motion.
Now, basically, the only difference here between a slump and a landslide is that the slump weakens at the bottom. The landslide tends to weaken more at the top. So it falls from the top, causing a different look. Generally less mass involved here, but the cover of the homes seems to be even more extensive.
And if you're in a snowy region, a landslide is really just called an avalanche.
Yep.
Another quick example is when rocks just fall. So when gravity pulls them from the top of the hill to the bottom of the hill, rocks falling is another form of this mass wasting.
Yeah, they spent hours and hours trying to figure out a name for it. It's called rockfall.
These mass movements, the slumps, the creeps, the landslides, the mud flows, all those can be caused by natural processes, but humans actually have a big part in this as well.
Yeah, we do move a lot of stuff. Construction is a big mover of debris from the land, is off-roading. A lot of quads and trucks and things that move through back roads move a lot of dirt as well.
And the things we can do to try to resist this gravity erosion is build trenches to divert the water to somewhere else, to catch rocks off of cliffs with steel cages like they have along the turnpike, or retaining walls to kind of shore up those weak slopes and try to hold back that creep of a hillside. The weathering agent here really is water or root pry from trees. The hydrolysis can weaken the rocks underneath it. You can also even see it as acidic rain, weakening the rock layers underneath. The agent here
of erosion is gravity. Obviously, that's just going to pull things down that have loosened to the tops of hills.
It can move them fast and move lots of material, so the mass of the material plus the speed. And the deposition part of gravity erosion
basically is when it hits the bottom, it just stops moving and deposits at the bottom of the hill.
Sounds good. So now we've got our 4 main eroders. We've got weathering, erosion, and deposition for each feature.
Got it.
See you later.